Hi, and welcome to our lesson 9.3, hyperbolas. Right here you have the geometric definition of a hyperbola. You don't need to write it down, but just notice that it is the difference of these 2 points, or these 2 line segments, D2 minus D1, as opposed to an ellipse, which was addition. The graph is 2 disconnected parts, and they are called branches. On this next slide, we have a lot to write down. So please pause the video, make sure that you get the standard form of the equation of each one of these written down. This equation has a transverse axis that is horizontal, means the branches of your hyperbola are going to open right and left. Here we have y first. Notice the subtraction. Your transverse axis here is vertical, which means that your branches are going to open up and down. So you need to write down these 2 equations. You also need to write down that the vertices are A units from the center, the foci are C units from the center, and if you need to find one of those 3 variables, A, B, or C, this is how you do it. A hyperbola, when we graph it, has asymptotes, and we'll talk about this a little bit more later, but please jot down the equation right here. Y equals plus or minus B over A times X. And this is when your when your hyperbola has a center at 0, 0. The next slide, all this guy is here is, it shows you your 2 standard equations, and then it just gives you a quick sketch of what the hyperbola looks like. X is first. You have a transverse axis which is horizontal. Your transverse axis is between your vertices. When y is first, your transverse axis is vertical. Notice that your hyperbola opens up and down, and here are your vertices. So I would pause the video for a couple minutes and just draw a quick sketch of each hyperbola matching the equations that you already wrote down. So let's go ahead and get started with an example. We have to find the equation of a hyperbola, and these are my 2 focuses, and these are my 2 vertices. I guess that should be foci, my 2 foci. So we're going to go ahead and find the equation, and we also have to graph it. So what I like to do is I'm going to go ahead and plot these points right away, and this gives me an idea of what my hyperbola is going to look like. I see here that my transverse axis is horizontal, and in order to write my equation, I need my center because I need my H and my K. So let's go ahead and find the center. If you remember the midpoint formula, the center is going to be the midpoint of my 2 vertices. We can find that pretty easily by just looking, but let's go ahead and make sure that we get 2, 2. We will take our 0 plus 4 divided by 2, comma, 2 plus 2 divided by 2 to get my center at 2, 2, just like I thought. We now know that A is equal to 2. Remember, that's the distance from my center to my vertices. I know that my C, the distance from my center to my foci, is 3. In order to be able to write the equation, I need to find B. I'm going to use the equation C squared equals A squared plus B squared to find that. C squared is equal to 9. A squared is equal to 4, which means that B squared has to be 5, and that makes B the square root of 5. Now I have all the information that I need. I have my H and my K, and I have my A and my B, and I can write the equation. And that equation will look like this. x minus h, quantity squared, over a squared minus y minus k, and here's my k, squared, over the square root of 5 squared, and that equals 1. That is my equation. Now let's go ahead and graph this really quickly. In the next example, I'll go ahead and find the asymptotes two different ways, but in this one, I'm going to go ahead and use the rectangle. Your asymptotes are the diagonals of a rectangle, and the rectangle is formed by your A and B. We use their distance from the center. So over here, notice that here's my center. My A horizontal is 2. That's how wide my triangle is. My length is going to be the square root of 5 from my center. That's about 2.24. I'll put a point there and there. What I want to do now is fill in the rectangle. And let's go ahead, and we have there. There's my rectangle. And now I'm going to go ahead and I'm going to draw in the diagonals. And that will give me my asymptotes. Oops. And get rid of that little guy there. And draw in my other asymptote. Drawing in the diagonals of this rectangle. And now I'm ready to go ahead and draw in my hyperbola. Here's the vertex. It follows the asymptote. Whoops. And now that happened. Wow. Oops, see if I can get that guy. There we go. Here is the graph of the hyperbola whose equation is right here. Let's go ahead and let's see what we have next. This slide gives you the formal definition of an asymptote where you potentially have a center other than 0, 0, so you have an h and a k. Notice if this was 0 and this was 0, so if your h and your k were 0, 0, you would get the formula that we wrote down a couple minutes ago. Each hyperbola has two asymptotes, and they intersect at the center of the hyperbola. They pass through the corners of the rectangle, so just over here, passing through the center of my hyperbola and passing through the corners of that rectangle. These are the dimensions of the rectangle with its center at HK. So go ahead and take a minute and write down these two formulas for the asymptotes of a hyperbola. So used when the center is not 0, 0. Let's go ahead and try one more example. We're going to go ahead and sketch the graph of this equation. So the first thing that I want to do is just write it down again. I have 4x squared minus y squared equals 16. Hopefully you guys notice that there's something wrong the way this is written, and it's the fact that it's equal to 16 and it needs to equal 1. The first thing I'm going to do is divide everything by 16, which leaves me with x squared over 4, and I'm going to write 4 as 2 squared because now I have my a, minus y squared, and I'm going to rewrite 16 as 4 squared, and that gives me my b, and that is now equal to 1 like it needs to be. Notice that my transverse axis is once again horizontal because my x is first. My vertices are a units away from my center. Well, my center is at 0, 0, and it is a horizontal transverse axis, and my vertices are 2 units away, so they're going to be here and here. That is going to give me negative 2, 0 and 2, 0, and those are my vertices. The endpoints of the other axes are going to use my b, whoops, there we go, which is 4, so they're going to be 4 up and 4 down. They are at 0, negative 4, and it doesn't look like a 4, and 0, 4. That is my rectangle, but let's go ahead and find our asymptotes using the formula. And that formula says that it is equal to y equals plus or minus b over a times x, and our b is 4 and our a is 2x. So this is an equation of a line, and it is 2 equations. That's going to be my asymptotes. So let's go ahead, and I'm going to plot some points here. My slope is 2, so up 2 over 1, up 2 over 1, and going over here, that gives me that. And then my other asymptote has a negative slope of negative 2. Let's go ahead now and fill in some dotted lines. And I'm going to pause the video while I draw those lines, and so when it pops back up, it will have them in there. So here's my rectangle, and here are my 2 asymptotes. So I am now ready to go ahead and sketch in my hyperbola, starting at my vertex and following along my asymptote in this direction and following along in that direction. So there you have it. There's the graph of your hyperbola. Please bring any questions you have regarding hyperbolas to class, and thanks and have a great day.